So I wanted to do a video now all about the redshift and the blueshift in quantum gravity, because the current quantum gravity theories that we have at the moment, such as string theory and loop quantum gravity, don't really explain the redshift and the blueshift so much. And this is something they really ought to be able to do if there's to be a theory of quantum gravity that unites general relativity with quantum mechanics. Because in general relativity, we have all these other facets of gravity to consider, such as the redshift and blueshift, such as the reflective capacity of stars, such as time dilation and gravitational waves and all these different phenomena that are associated with gravity that we now know about, which are incredibly well tested, and which should have their origins in some sort of quantum mechanical phenomena. So to press forward with the explanation for the redshift and the blueshift I'm going to give in this video, we first have to, of course, understand what redshift and blueshift are. So for galaxies that are moving away from us in space, which is most galaxies, the light from those galaxies is being redshifted, which means it's being pushed towards the lower end of the electromagnetic spectrum, if you like, towards radio waves and microwaves in the sort of the red end of the electromagnetic spectrum, where there's lower energy photons. So for some reason, as the light from redshifted galaxies is moving through space, it's losing energy, basically. And the reverse is true for blue shifted galaxies moving towards us. The amount of space between those galaxies and our own galaxy is decreasing. So per unit volume, there's more and more energy being transmitted between those galaxies and ourselves. An example of a blue shifted galaxy is the Andromeda galaxy, and there's a few other galaxies I think which are blue shifted, but not very many of them. Most galaxies in the universe are moving away from us. So for some reason, we have to invoke a kind of a quantum mechanical idea to be able to explain why the energies from one galaxy are increasing versus why the energies from redshifted galaxies are decreasing. So the notion in quantum gravity that I invoke to explain gravity is this idea of electron densities, where I'm thinking that in the recesses of space between galaxies, there are tunneling electrons popping up all the time and disappearing all the time when they interact with other particles, and these are responsible for the effect of gravity. So, for example, there's electrons popping up in space, depositing photons in space, and this leads to the cosmological constant. When atoms pass by these electrons, the electrons transmit particles between the nucleus of the atoms and lead to the attractive element of the gravitational force. When particles accelerate through space, if you were to accelerate, for example, a clock very close to the speed of light, the hands on the clock would stop ticking because it would be crowded with electrons in the background. All the electrons in the background would be exerting repulsive forces over the electrons in the hands of the clock and therefore prevent the clock from ticking. And when it comes to the redshift, you've got to imagine that the space between the redshifted galaxy and our own is increasing. So there's progressively more and more electrons in the background in the increasingly large space in the increasingly large space between the galaxies. And this is just basically sucking up the radiation that's getting emitted from the galaxy moving away from us to our own galaxy. So this is why light also loses energy as it travels through space. It's just basically being gobbled up by background electrons. So what's a little bit more complicated than that? Really, what's going on is that at a quantum level, the photons moving through space are taken up by an electron. The electron tunnels to somewhere else in the universe, is replaced by another electron with a photon of a similar energy inside it, and the electron releases the photon. It hangs around in space for a little while, then another photon comes along, collapses the electron's wave function, and then it tunnels to somewhere else in the universe. So whenever photons move through space, they're always moving through space in this zigzaggy pattern. And whenever we detect a photon, we're never really detecting, well, we are sort of, but when we think about photons moving through space, we're always thinking about them being virtual particles as opposed to kind of any kind of particle that has definite continuity within space. Because the real particle, the point particle that is the photon, is constantly moving between electrons. So it's really only a point particle between one electron and another electron. When the next electron absorbs it, that electron tunnels to somewhere else in the universe, is replaced by another electron which emits another photon, a different photon, and it goes on like this. So the fundamental quantum reason why electrons are blue shifted or red shifted is because the electron that absorbed the photon has been replaced by another electron with a slightly lower energy photon within it. And this is because I suppose you can think of, if an electron absorbs a higher energy photon, you can think of it as the electrons are growing slightly in space and taking up a bit more space before it tunnels, and that leaves a slightly larger hole in the background, where an electron of yet a slightly larger extent in space is going to be able to tunnel to that location and release a slightly more energetic photon. So that's a rough sketch, I think, of the quantum mechanical reasons why redshift and blueshift happens. But more broadly, you can think of with the blue shift is occurring because more and more photons are entering a unit volume as the galaxy approaches it. So there's constantly more and more energy that's not being taken up by background electrons. And for this reason, there's an increasingly large amount of energy entering every intervening unit of volume as the galaxy approaches. And I think that's a slightly better explanation than what I gave before. I mean, sorry, I've been kind of struggling to kind of wrap my head around this concept because I wanted to do a video about it today, and I have a kind of a rough idea of how all this stuff works, but it's not necessarily very complete. And if anyone else out there who has a physics background or wants to get involved with the process of helping me solve all this stuff, I'd be very happy to collaborate with anyone. But I mean, yeah, this is kind of the rough quantum mechanical reason why this happens, is because there's, with redshifted galaxies, a growing space between the galaxy emitting the light and the galaxy receiving the light. So in that intervening space, there's a larger and larger amount of electrons progressively over time. So the energy from one galaxy is being attenuated, weakened by this increasingly large amount of electrons. And for a galaxy moving towards us, whose light is blue shifted, there's progressively more and more photons per unit volume, so more and more light is getting through as the galaxy gets closer to us, and the number of electrons in that intervening space is getting smaller. So there's fewer and fewer electrons to take up that light in the intervening space. And I think this at least does give a better explanation of the blue shift and red shift than string theory, for instance, does, or loop quantum gravity does, or Euclidean quantum gravity does, and does bring in kind of workable quantum assumptions that we know about involving electrons, which is a particle we're all very familiar with, and we're quite familiar with its behavior so far as it involves interactions with photons. So yeah, I felt that's a kind of a tenable explanation for the blue shift and red shift, and one which probably warrants further investigation and I think wider acceptance by people and investigation by more people than just myself. But I suppose to get that to happen, I'd need to publish my research somewhere, which is a very, very hard thing for someone who's not in the academic physics community to do. And I don't really know how to go about doing all that sort of stuff. But yeah, nonetheless, I hope you enjoyed this video. I hope you learned something. I hope I gave a coherent explanation of redshift and blueshift. And yeah, well, I mean, this, just to recap, it kind of happens because, for the same reason that light loses energy as it moves through space. So light moving through space obviously loses energy as it moves through space. We don't receive all of the light that the sun emits, for example. The light gets weaker as it travels through space. And this is because there's electrons in the background tunneling, snatching a photon, tunneling to somewhere else in the universe, depositing it, and so on and so forth. And as objects recede in space, as they move away from us, there's more and more electrons there to do that. There's just more electrons in the space there. And as objects move towards us, are blue shifted, it's because there's fewer and fewer electrons to do that, and basically more of the light over time reaches us as a consequence of that. So that's my explanation of blue shift and red shift. Thanks for watching, everybody. Love you lots. Bye bye bye. See you soon.